find IXL R1 and R2. Okay, just ignore that little arrow on there. R1 and R2 is all about you looking at logarithms. And we know that there is a logarithm button on our calculator. If you have downloaded the TI-84 app that's called Calculate 84, it may help you if you can't figure out what we're doing here today. So it's easier just to try to look at the problem and do it, but if you have trouble, you can download that app and take care of it that way. Let's look at what R1 is all about. And what you're going to find with logarithms. A logarithm problem looks like this. Log base 3 of 9 equals what? Well, it's equal to 2. How do I know that? Well, a logarithm is related to exponents the way addition and subtraction are related. Like 2 plus 3 is 5. This addition fact allows me to write a subtraction fact. And this fact with exponents, 3 squared is 9, allows me to write this logarithmic fact. So all that a logarithm is, it's when they are asking what exponent needs to go on the 3 to give you this 9. So the answer to a logarithm is always the exponent needed. So let's take a look at some exponential form and log form, because in R1 that's what you're going to be expected to do to write the exponential equation. Okay, suppose I had 9 to the first equals 9. Well, this is my base. This is my exponent. This is the answer. All you have to know is that when it goes to log form, you're going to do log. You're going to put your base down here. The answer to the exponent is there, like this 9. And then it will always be equal to whatever the exponent was. So for instance, this one that we have here, you would write log. The base goes little and low, so this base right here is a 9. A is for answer, so 9 would be right here. And remember, a logarithm is always equal to the exponent, so the exponent here was a 1. Okay? So on your IXL, they would give you maybe something like this. They would give you 9 squared equals 81. And then they would have log base 9, would have a box here, and it would be equal to 2. It's asking you to figure out what goes in the box. So remember, this is always your base. This is all, the exponent is always out here. So the answer, 81, is what would go in your box. Okay, we'll take a look at some more in just a second. All right, let's try this one. 3 squared equals 9. Log base 3, 9 equals what? We always said that a logarithm is always equal to the exponent. So what's the exponent up here? Well, the exponent was a 2. So that means the answer here is 2. Okay, let's take a look at another one. What if you have been given the log form? Okay, log base 2 of 1 equals 0. And then they give you exponential form. Okay, you can pretty much figure out what goes in the box by looking at what's missing. Here's my base, here's my base. See? The exponent is what's missing. And remember, every logarithm, you have your base, you have your answer, it's equal to the exponent. So there's my exponent. And that's what's missing. So this 0 right here is going to come down here. It's what we need to fill in the blank. Okay, let's keep going. Let's look at this one. Log base 9 of 81 equals 2. So here's my base. Here's the answer. Here's the exponent. Another thing I always tell people, you can draw the loop and follow the loop, and the loop will tell you the order that you need. So there's my base, so 9 would come first. Then next we need our exponent, and it will be equal to whatever the arrow is pointing at, so it would be an 81. So you would just fill in whatever's missing on your IXL right there. Okay, let's see what else we're going to get. All right, now sometimes you may see a logarithm that looks like this. This is what we call the common log. It's called a common log because, well, it's common. They use it a lot. And the common log is a log that has an invisible base 10. So if you don't see a little number that's little and low, that means that's a base 10, and you just need to, you can fill that in your mind or just imagine that it's there. So if I draw my loop, my base 10 would come first, where a logarithm is always equal to the exponent, so the exponent would be up here, and that arrow is pointing to the 1. So whatever is missing, you can then fill it in. Okay. I'm going through your IXL lesson and just making sure I have every type of equation here for you. So this one's a little different. Okay. This one is showing you this. So here's the exponent. This is the base, but there's nothing here. And once again, why is there nothing here? This is base 10. When it's base 10, that's the common log. We don't put anything here when it's base 10. So when you draw the loop, base 10 would be first. When you follow the line, 1000 would be what would go in the box. Of course, it's equal to 3. Okay, so that's about as hard as it gets. You're just practicing what goes where in these log equations and these exponential form equations. I think you can handle that. Let's look at the next one. When you get to R2, you're going to deal with something called ln. And what ln is, it's the log natural, but we call it natural log. Of course, people in other countries put the log first and the adjective afterwards, like log natural. But anyway, nonetheless, it is natural log. That's how we say that here. And what a natural log is, ln is the same thing as log base e. And you're like, well, there's nothing natural about that. Well, e is a very famous number. It is a number named after a guy named Euler. Pronounce that Euler. It's 2.71, blah, blah, blah. It's irrational, goes on forever. But it's used so much in science that we have a whole logarithm notation just for it. They made it smaller. So here's how that's going to show up on your stuff. Like if I had e to the 4th is approximately equal 5.54.598, you may have a question like this. Okay, this ln means log base e. So your e has already been accounted for. The 4 has already been accounted for. So obviously the 54.5 0.598 is what would go in there. So you just write that in there and you'll have it. Okay, let's take a look at another one. All right, natural log of 9 equals 2.197. And it's saying e to the 2.197 is equal to what? Well, remember, ln is just a logarithm with a special base e. So e to that power, draw your loop, it's equal to the 9. The 9 was what was missing there. Okay. Next one, natural log of 20.086 is approximately 3. So basically, you would have one that looks like this. Okay, so this means log base e. So what's missing here, you can tell, is the base. So if it's natural log, the base that has the exponent has to be an e. And I know this e stuff is hard to understand. They introduce it in mathematics and algebra too, but to understand it, it really takes calculus to understand. So if you're confused about that, maybe one day if you ever take calculus, you will understand where that number comes from. It's kind of a number like pi. It shows up. There's a relationship. But you don't have to understand that in order to do these logarithms. The only thing you have to know here is that log base e is written short with ln for natural log. Okay, that's it on R1 and R2.